Okay, in this tutorial we're going to be looking at constructors for the language C++, and essentially I kind of expect you to know a little bit about C++ or C already, like for instance to know what the members of this structure are, what we've kind of declared over here. And hopefully if you have at least some object-oriented experience, you'll know that these are member functions. For instance, the function void, that returns a type void, and it deposits some amount of cash which changes the cash balance, and it operates on these members of an account. I will just do a small example in case you're wondering. We can make an account my ac, leave it uninitialized. You should probably actually initialize it though. And in order to do that, let's make a person Harry and $300. So you can notice that we've initialized it with Harry, which is of type person, and that's our client variable, member variable, which is of type person, which is why we declared this. And then we have to call one of these member functions, one of these, on the myAccount object. So what we can do is, let's say we want to deposit $200 into the account. So now in the account there really should be $500. We can check this by peeking at that value, and oops, may have spelled something wrong. Oh, I forgot this equal sign. Sorry about that. And if we check, we really do get $500. So essentially, member functions aren't that hard to figure out. They have a return type. They can only be called by an object of that structure class. So, on to the actual topic at hand, constructors. Now, if we look at this person Harry we've declared and think about, well, does Harry have any, like, what's his age? We get the interesting value of 4,197,000. We get a garbage value, right? We don't want garbage values inside of our structures because then it forces us to do things like this. We have to declare the name, which can be, let's say, Harry Hardluck, and his age can be, let's say, 40. And while this works, and it doesn't look too bad, it really causes problems if we're trying to declare compound structures. And obviously this is a compound structure because it has structure as one of its fields. So in order to declare this, we would have to declare Harry in the initializer, and then this $300 value over here. Say we didn't actually want to declare or initialize a Harry variable, then what we'd have to do is we'd have to take this entire thing and replace it over here. And you can see that this is not going to be fun to look at, because already it's getting a bit difficult to read because you've had to initialize a structure instead of a structure, and though this works, it's just somewhat cumbersome and not very flexible. And it's not as intuitive either. So what we need is a way to overcome this sort of problem, and this is where constructors come in. Constructors allow us a lot more flexibility when dealing with objects. So for instance, if I don't have this, Harry is still going to be initialized to some default value which won't be garbage values. And the cool thing is I can specify which default values it'll be specified to. When we're going to be looking at this, I'm not going to look at the account structure. I'm simply going to be looking more at the person structure, simply because it's more simple, and once we get a better understanding of what's happening, we can move on to the account structure and figure out, okay, what really happens when we create when we call a constructor. So first, you should know that constructor is a member function, just like any other member function. For instance, you can notice that deposit and withdraw are member functions, but constructors have no return type. So you don't have anything to write here. You don't even return a person. But The cool thing is that all constructors, their names have to be the name of the class or struct that they're operating on. So I have no choice but to call the name of the function person. Next is the number of arguments. Let's say that I wanted to just have something for a default sort of constructor. And over here, what I can do is I can specify, well, I'm going to have name be John Doe, so I don't know who it is, and I can specify age to be some sort of default value, let's say 30. And if I do this, the default constructor will run when I try to create an object Harry. Now, just to convince you that the default constructor is actually running, I'm going to cout person no arg constructor ran. So if I make this, we see that the person no argument constructor ran. And just to check whether the internals are looking good, we can say Harry, cout Harry dot, age. Oops. So the no argument constructor runs and we get proper default values, or at least any default value that we supply. So already we've seen one advantage of creating our own constructors. We have an ease with which we can declare and instantiate objects of a class without having to worry about what their values are going to be and making sure that they aren't actually just filled with default garbage values. The other cool thing is that we have more flexibility in how we can instantiate these. For instance, let's say that you really want to be able to specify what the actual name needs to be. So let's say string, my name and int my age. And what now happens is we can say, well, name equals my name and age equals my age. And just for kicks, just to make sure, we can say person to arg constructor ran. And let's just close this off. So with this person Harry, I'm going to say an explicit initialization person, let's call them Harry Hardluck, and he's going to be 44 years old. So this should cause no problems. And we can see that the toArgument constructor ran. So what is the flexibility here? Well, C++ provides us with operator overloading, functional overloading. A constructor, this is the same exact function, and we get to use different kinds of parameters. So C++ has this little overhead that goes around and checks, well, how many parameters are here? Okay, there's 2. Well, there's a constructor that takes 2 parameters. Perfect. I can use that to initialize this value to whatever the constructor body has me initialize the values to. And this gives us a lot of control, because now we can actually do something, let's say Sally equals a person with no parameters. Then Sally, if we look, we can see that the toArgument constructor ran and then the person's noArgument constructor ran, which means we can initialize people however we want. We can initialize them with 2 arguments, or we can initialize them with 1 argument. Now you might think that this looks a little bit clunky. For instance, we're making an explicit constructor call. You don't actually have to do this. What you can do is you can initialize them as such, an implicit constructor call. Now for a 0-argument constructor, you can't actually do this, because now it looks like you're trying to declare a function Sally that takes no arguments and returns a person. So if you're declaring or creating an instance of an object that takes no parameters, forego the brackets. And if you do this, everything should still be fine. And you'll notice that the same constructors are called. The same toArgument constructor is called, and the same noArgument constructor is called. Finally, these constructors allow you to do a bit of reinforcement. For instance, say you want to design, this class where if somebody's going to initiate or instantiate it, they must always provide two arguments. They can't provide one argument, they can't provide three, they must provide two. And they also can't just provide no arguments. You can delete this entire constructor, and now if I try to do this, the compiler will complain a lot. Simply because the default constructor is no longer there. Now here's the thing, when we didn't have this constructor, C++ was able to initialize this without problem. Granted, the values inside the fields were garbage, but it was able to actually initialize it. So here's the thing, when you create your own constructors, C++ realizes that you're taking control over the class or structure and says, okay, I'm going to remove all of my constructors and hand over full control to you. Which is why that default constructor disappears, and you have to create it yourself. And this gives you that that control that you would like, in which you're forcing your clients to initialize the fields to whatever you want them to be, or not what you want them to be, but what they really need to be. So, in the next video, we're going to talk about a few more cool things that constructors can do, and also maybe about what happens inside of constructors that have compound classes. Anyways, to recap, constructors give us a lot of flexibility and control over how we initialize objects, and they can do so in a streamlined approach because of function overloading. I'll see you in the next one.